Good morning, everybody. What we're looking at today is 14H out of the Cambridge textbook. And I've called this lesson Life's a Beach because that's mostly where I'd rather be right now, even though I'm not normally an outside person. Being cooped up inside here for 2 weeks now is starting to take a toll on us. So, what we are doing today is we're looking at circular functions and graphs and how they have multiple solutions. So the idea is that we need to be able to set up a pattern to help us find solutions to trig functions over particular windows. So what I've got here on Desmos is y equals sine of x. Now again, this is all in radians. You can, to customize the way it looks, so it gets to look something like what I've got, you can play with the wrench in the top right corner. And if you type in the letters pi, it turns it into a pi symbol for you. So I'm actually just going to go to negative pi for this next bit. And it turns it into the pi symbol, as you can see there. I also made sure it's in radians, because if I change it to degrees, it doesn't work. Alright. So what I've got there is I've got y equals sine of x. And I've got a second line, y equals 0.5. And what it's done is it's put this in here for me so I can easily drag it up and down. What I've also done is on the x-axis, I've labeled the step as just pi. And what it does is it actually puts in the extra markings for you so that you can work it out yourself. So, looking at this graph, over the range of 0 to 4 pi, how many answers do we have? Looking at just this picture I have right now, over 0 to 4 pi, how many answers do I have? I'm thinking about the red line and the blue line. How many times do we have sine of x is equal to 0.5? 4. So, the question is, from now, how do we figure out where they are? Now, luckily for Desmos, I can click on the intercept, mouse over it, and if I've got it set up properly, it will actually tell me. So that's pi on 6, which, if you remember your exact functions, makes sense. Sine of pi on 6 or sine of 30 is 0.5. And if I mouse across, it gives me the next one. And then the one after that. And then the one after that. And it just goes through and gives me what I need. So it's pi on 6, 5 pi on 6, 13 pi on 6, 17 pi on 6. So, with this information, we can now start to realize that if I were to expand the domain, it would go even further. And we would have infinite solutions going left and right. So positive and negative, they would all have a set of intercepts, but they would all follow a pattern. All right. So this one is this is pi on 6 from 0. This one is pi on 6 from pi. So if you notice here 0, the first one is at pi on 6. Now if you think about your symmetry properties between 0 to 2 pi, you can start to realize that they follow your symmetry properties pretty closely. So it's going to be pi on 6 from 0, but it's also going to be pi on 6 from pi, going backwards, which is where you get pi on 6, 5 pi on 6. And then you repeat, because it's 2 full periods that we care about, you add 2 pi to both answers to get your second lot of answers. So if we change this to something else, where is it? Root 3 on 2. Again, we're trying to stick to numbers that we know the exact answers to with regards to our functions. So there you go. Pi on 3. So it's pi on 3 from 0, but it's also pi on 3 from pi, but just in the opposite direction. And then we simply add 2 pi to both answers to get to where we need to go. All right, the same is going to be true if we change this to cos of x. Four answers, just slightly different patterns. Still involving, amounts of pi on 6, pi on 3, etc. But you've got that. That's what you've got your symmetry properties and your exact values tables for. So, where it gets tricky is when we start putting in period shifts and amplitude shifts. So if I put a 2 on it, everything changes. But if you look closely at the graph, they are still the same distance symmetrically. The graph is still symmetrical, and the answers are still going to be at these same intervals. Now, obviously, it's not because of the amplitude shift. It's not neat pi on 6s anymore. But if you see here, it's 1.123. So it's 1.123 from 0. And this one is 1.123 from 2 pi. And this next one is going to be 2 pi plus 1.123. Now, 2 pi is approximately 6.28. So if you were to actually take 6.28 and subtract 1.12 from it, hey presto, you've got your 5.16 again. So as long as you have your milestones i.e. things about pi, etc., you can use that, find the first answer however you need to. But then, knowing whether it's cos or sine, have patterns to help you figure out where all your other answers are. Of course, this is only over a particular period. And again, the same principle happens if we, instead of changing that, we change this to a number that is not nice and neat. So for example here, this is 0.1, y equals 0.1. Now, it's not going to have a nice clean answer. However, if you can find the first answer, you can use your symmetry properties to figure out the rest from there. So in this case here, this first one, cos of 0.1. When does cos of x equal 0.1? Well, it's at 1.471. And through symmetry properties, we know that every other answer is going to be pi onwards because of the way cos of x works. If you look here, this is pi over 2. So this is going to be 1.417 from 0, and then the next one's at 2 pi. They're going to be plus or minus that same amount to get these next two. And then the next one is going to be 4 pi minus that original number. So out of your textbook, there is a section summary that I want you to make sure is in your book. Because you will need it. And I want you to make sure that you have a look at the written worked examples of the textbook that go with this, because it is it's a very good explanation for you guys. So this is the table that goes with what we've been talking about.